We were looking at different integration projects that we could do in automation settings, and in almost every environment that you go into, there's always a logistics portion. Moving something from A to B. Palletizing is a pretty common application. A lot of different people have tried to tackle it. So I've been a huge humanoid robotic nerd for 13 years now. I was the PI on an Air Force SBIR contract, Army SBIR as well, did some work for NASA, the Navy, got pretty lucky. Done a lot of defense-related stuff. And somehow inside of that, trying to tackle the physical laws of the universe, you also have to deal with really silly things like software infrastructure, code rot, trying to figure out how to have multiple units running in different versions of software. When you're making a new automation cell, it's important to split it down to the hardware components. So we used Viam to define those individual components. One of the great things about setting up the palletizer in Viam were the services that were provided by default, kind of built into the platform. In this, we have a frame system that lets you define where these individual hardware components live around the robot. And it comes with a service called the motion planer. And that allows you to say, I want the arm, or I want this thing mounted to the arm in the frame system to go pick up this component or part or box or just whatever you're trying to move, and then naturally move it from there to a target position. It also allowed us to determine if we were going to have any collisions beforehand, and came up with a way to move through environment exactly like a human would, with no collisions, no crazy trajectories that you might get if you try to do this by hand. A big portion of this project was done in simulation. We loaded our simulated arm, we created a simulated gripper, and that allowed us to prototype the solution very quickly. The simulation portion was high enough fidelity that everything we developed just worked when you went to the hardware, and it ended up meaning that we only needed half a day to get this to work on real hardware. And one of the big issues that we have is related to the release cycles. So if you have 5 or 6 different libraries, or 100 libraries, making sure they're all in the right version and that they're all talking to each other can be very difficult. One of the things that we use here at Viam is a controlled release cycle on which you can specify exactly which libraries need to be pinned or released or managed, and defining how those release cycles get pushed to the fleet has been an incredible improvement. Being able to pinned versions inside the machine configuration has meant that I can selectively control which system has which component in a very intuitive way. And it has made updating and upgrading different things and trying out things so much better. It has been an incredible pain point my entire robotics career. I have went through and tried completely changing the palletizer to operate on a different framework. I wanted to include a bunch of new libraries. I wanted to pull out the vision system for an OBB-based box detector. I was able to test that out on local hardware, then roll it out on a customer floor site testing ground, and then come back and realize what was wrong, and then immediately switch back to a stable version. That has been a huge differentiator, and I love it. Our platform isn't about one specific solution. It's about making lots of different solutions with a platform and a lot of reusable components. So we use this as a proof of concept, and it's something that we were able to put out very quickly. As you can see, it's pretty robust, and we think that taking modules that we're developing from this solution would be applicable to a number of different problems inside of an industrial warehouse or any type of automation.